Hello everyone. This is Team. The basic theme of our project is agriculture, food tech, and rural development. The software basically identifies plants from photos using YOLO, which locates the leaf within the image by cropping the background and drawing bounding boxes. The image is then analyzed with a machine learning algorithm called TensorFlow. It helps in plant identification. It also uses OCR to identify the name of the crop and QSAR to identify the disease by reaction method. This is really helpful for farmers, botanists, and other users in all possible ways. The project leverages several AI algorithms for accurate identification and disease analysis. Going to the technical end, first comes the front end. Here we use HTML, CSS, JavaScript. As all other websites, HTML is the backbone of our project. Bootstrap is a CSS tool used for enhancing the website and making it more creative, and React.js for building the user interface.
The backend is where the core logic, data processing, and server-side happens. We use Flask to create a server-side with Python, and the front-end image from the front-end is brought to the backend, and after processing, it is again sent back to the front-end with the help of Flask. TensorFlow, which is a machine learning library, is used for analyzing the image and giving the user the required knowledge. The user interacts with the front end, such as by uploading a plant photo, and the image is sent to the Flask backend through an API call. Flask receives the image and uses TensorFlow to analyze it. If needed, Flask queries the SQL database for additional data. Flask sends the analysis results back to React.js, which updates the UI to display the findings and suggestions to the user. The next step would be feasibility for the web page. This would require a large and diverse dataset to make the web page more realistic. The need for training the AI model with computational power is critical to complete the project successfully. We need to acquire adequate agricultural and AI knowledge so as to create the user trust while addressing the challenges. We need to focus on the quality of data. If the data is poor, then results may be inaccurate, and regularization and cross-validation methods are required. It may be difficult to identify the photos because of the background and other unwanted environments. Therefore, proper training of the AI model is mandatory. The social impacts are it reduces crop loss as it is protected before being affected by serious diseases. For small-scale farmers who cannot afford to upgrade to advanced technologies, this web page will be helpful for them to find the disease and cure it. This also reduces the cost of unwanted chemicals and pesticides. On the other hand, since the quality of the plant is good, so we will get better yields. Considering the environment, accepting the minimal use of pesticides will protect the soil and water health and support sustainable farming. At the same time, this project enhances food security and reduces waste. By this way, we can protect our ecosystem and create a healthy generation.